All right, so we are working with rational expressions. A rational expression is essentially just a quotient of polynomials, a quotient or fraction of polynomials. We see some simple examples right here: x squared minus 1 over x plus 3, n minus 4 over 2n minus 8, and negative 6, which is still a polynomial, over 2y squared plus 10. We're going to learn to work with these just like you learned how to work with fractions. But since we do have polynomials inside of our fractions, we have to have some new ideas. The first of which is restricted values. Since I cannot divide by 0, that means no denominator can equal 0. So I'm going to get restrictions. So right here, I have x plus 5 over x squared plus 5x minus 14. Well, that denominator can be factored. What multiplies to negative 14 and adds up to 5? Well, that would be plus 7 and minus 2. So, since the denominator cannot equal 0, that will mean that, of course, x cannot equal negative 7 or 2 from those two factors. If x were negative 7 or 2, again, what would I have? Division by 0. Let's take a look at some more examples. X minus 4 over x cubed minus 16x. If I factor out an x down here, I can see that this is x times x squared minus 16. So what I can write is that this is x minus 4 over x times x plus 4, x minus 4. So if I look at those three distinct factors in the denominator, I can see what restrictions do I have? X cannot equal 0, negative 4, or positive 4. So I can just write plus or minus 4. One more example, 3 minus z squared over 8z cubed plus 125. Now we might want to rewrite this in descending order, We'll do more with that later. But in my denominator, this is where I'm focused because I'm trying to find restrictions. 8z cubed plus 125. I recognize this as the sum of cubes. 8z cubed is 2z cubed. 125 is 5 cubed. So, then I get this trinomial. That trinomial, remember, I'm going to square 2z to get 4z squared. Then I'm going to do minus the product, which is 10z. And then I'm going to have plus 25. So I want to know about what restrictions I have, for this denominator. Well, if I set 2z plus 5 equal to 0, I'll subtract 5 and divide by 2, so z is negative 5 halves. For this trinomial right over here, you might recall we've discussed how this thing does not factor. And what's more, its zeros are non-real. They are imaginary numbers, or complex numbers, rather. But z equals negative 5 halves, that is our restriction. Z cannot equal negative 5 halves. All right, so now that we have that out of the way, let's work on simplifying a rational expression. When you first learned fractions, right after you learned how to simplify fractions. The process is essentially the same for rational expressions. You're going to factor both the numerator and the denominator, and you're going to divide out common factors. Now, as you do this, you want to make a note of restricted values. You may be asked for them as part of your answer. And again, the idea is really these things don't make sense if we're dividing by 0. Division by 0 doesn't make sense, nor would it make sense if we had a situation where we had 0 divided by 0. Now, going back to this idea of dividing out common factors, you want to think about the fact of if I gave you a problem such as this, x minus 4 divided by x minus 4, those are, of course, the same factor. X minus 4 divided by x minus 4 is equal to 1 in almost all cases. When does this not equal 1? Well, if x was equal to 4, then this would be 0 over 0. So that is my restriction. That's where the restriction comes from. Another thing to make note of, this was referenced in a previous video, but when you see something like x minus 3 over x, please be aware, this will not simplify. X is not a factor of x minus 3. You can only divide out common factors. All right, let's take a look at a couple examples now. Negative y squared plus 9y plus 22. So I can take out a leading negative, y squared minus 9y minus 22, and I can factor that pretty easily. What multiplies to negative 22 and adds to negative 9? The answer is negative 11 and positive 2. In my denominator, I have to do a little bit more work to factor this. What multiplies to negative 24y squared and adds to 2y? Well, that would be plus 6y and negative 4y. There you go. If I group these, I can see the common factor is 3y, leaving me with y plus 2. And here I can see the common factor is negative 4, leaving me again with y plus 2. So my factors are 3y minus 4 and y plus 2. So what common factors do I have? Well, right there I can see I have y plus 2 as a factor of the numerator and the denominator. Y plus 2 divided by y plus 2 is essentially 1. So what do I get? I have negative y minus 11, and 3y minus 4 is my denominator. Now what restricted values do I have? X cannot equal, from here I get x cannot equal 4/3, but I need to remember y plus 2 was part of my denominator originally. So why did I write x? Sorry. Y cannot equal 4/3, and y cannot equal negative 2. Even though I've divided out that common factor, in this original expression, had I put in negative 2, I would have had 0 over 0, which doesn't make sense. Down here, if I put in negative 2, I wouldn't get that. So these are equal, provided y does not take on any of those restricted values. Let's do one more example. Here, I have 12x squared minus 42x minus 180 over 6x squared plus 15x. All right. So I can factor the denominator very easily. 6x squared and 15x, the common factor is 3x. I take that out and I will be left with 2x plus 5. In my numerator, 12x squared minus 42x minus 180, I can see from there, I'm going to do some work down here, that 6 is a common factor. If I take that out, I will have 2x squared minus 7x minus 30. And then I'm going to try and factor this. Well, 2x squared negative 30 is negative 60x squared. What multiplies to negative 60 and adds to negative 7? Well, the answer is negative 12x positive 5x. And then I can see I have 2x times x minus 6 plus 5 times x minus 6. And I now have a factorization. I have 6 times 2x plus 5 times x minus 6. All right, what common factors do I have? I can see right there 2x plus 5 and 2x plus 5. Those are common factors. They divide to 1. Now I also see 6 right here and 3. Those integer factors can also be simplified. 6 divided by 3 is, of course, 2. So what am I left with? I am left with 2 times x minus 6 over simply x. Now mind you again, x is not a factor of the numerator. This cannot be simplified anymore. I could distribute the 2 for my answer, or I could leave it like this. It's really not important. And again, I want to make note of what restricted values I had. Well, x could not equal 0, clearly. And x could also not equal negative 5/2.